Hi, so I'm going to be walking through question 4 of the first round of the Maths Olympiad Teams competition. So this is quite a neat problem, and it's to do with circles and triangles. And yeah, if you didn't get this question, then after seeing this diagram, it may become a bit more clear how you would go around getting this question now. So you can see if you join the centers, we'll let the center of the smaller triangle be O, and if you drop the centers to the tangent, well, they're going to be right angles from one of the circle theorems, and if we let them be P, Q, and R from dropping A, O, and B, the perpendiculars from the centers down, there'll be P, Q, and R. So from this, if we construct another line parallel to P, Q, and R going through the center of O, well, parallel lines have the same right angle, and we let the points of intersection of the perpendiculars going from A to P and B to R, we can call these points of intersection x2 and x1. So this is the intersections of two lines, and they meet at these points. These points will also have a right angle, and from this we can now do some maths. So if we call this the radius of the small triangle R, then obviously these lines are parallel, then this will also be R here. We can call the length from O to x1, so let me do this over here in a bit bigger. Oh, that's a bit too big, let's try that. OX1 will equal 4 minus R, because you take the whole length and you minus the radius. So from, when I said O, I meant B. My mistake. B to x1, so from the center of the big triangle to the point x1 will be 4 minus R. And if you want to find, if you want to find the length of OB, or OB will be the radius plus 4. So you've got 4 here, and then you've got the radius. So you've got 4 plus R, and you're missing the length of O to x1, and you can find that through Pythagoras, but at the moment it's unknown. We can do the same sort of logic with OA, the triangle OAX2, and we can say that A to x2, well, that's just going to be the radius of 1 minus R, and the length of OA, which is from the center A to the center O, well, that's just going to be 1 plus R, and the other base of the right triangle, which is from x2 to R, x2 to O, sorry, well, that's an unknown. We can use Pythagoras, because these are both right triangles. We can use Pythagoras, and here I'll show you how we use Pythagoras. So on this triangle here, first of all, we've got QR squared, which is this length here. This length is equivalent to OX1, so we can use QR squared and OX1 interchangeably. So the base squared plus the height of the triangle squared is equivalent to the hypotenuse squared. So using that in, you can do QR squared, which is an unknown, is equivalent to x1b squared, which is the height, and that is equal to the hypotenuse squared. And going through that with logic, we then simplify QR squared to equal 16R. So we take away the squares of the base and the height, and it happens that there's a difference of two squares, so they factorize quite neatly, which takes out the need to expand. And then you eventually get that QR is equal to 4 root R. that's in terms of the radius r here. So you can do the exact same logic with the other triangle OAX2, and you can find that PQ plus X2A plus O2 squared, so Pythagoras on this, following through gives QP to be 2 root r. So now we've got, in terms of this length here, X2O and OX1, and we know if you add these two lengths, you get the whole length P to R here. So if we can find P to R in terms of R, then we can effectively solve that equation. And that is what we're going to do. And there is one more final right triangle which we need to do sums on, and it's the triangle ABX3. So if you move this line another bit up and you let it be perpendicular from A and go across all the way to the other side perpendicular, you get a right triangle with hypotenuse being 1 plus 4. So the hypotenuse of that is 5, and you know the height of that is going to be, well, it's going to be 4 minus 1, because this is the radius of this one. So the height of this one will be 4 minus 1, which is 3, sorry. So you will see this triangle here has got sides. Here's the equation for this triangle. It's got like this, it's got 5, 3, and obviously you all know it's a 3, 4, 5 right triangle, so we know PR, which is the base, will be 4. So from that logic we can say A to X3 is A to X3, which is the exact same thing as PR, is equivalent to 4. So you can see the sums here using Pythagoras. PR squared plus 4 minus 1 squared equals 1 plus 4 squared. So we then get PR to be 4. We also know that PR is the sum of PQ plus QR. So this whole length is the sum of these two lengths here. So you can set up equation with plugging back in QR, which is 4 root r, and QP, which is 2 root r, equals to 4. You solve that equation and you get the radius is equal to 4/9. And that is your solution. That is the radius of the smaller circle.